So let's continue empirical formula. How, if I have an unknown compound, I have made in a chemical reaction, I don't know what the structure is. First, I need to obtain empirical formula. Suppose I'm dealing with a hydrocarbon. What are hydrocarbons? Compound made out of carbon and hydrogen. Let's say CN, H2N plus 2. That's the general formula of saturated hydrocarbons, which are made of carbon and hydrogen. And I don't know number of hydrogen relative to number of N. Why don't I put here question mark? Well, how do I do the analysis to obtain the percentage of carbon and percentage of hydrogen? That's how we do it. We send the sample to a lab. In the lab, they take the unknown compound here, suppose we don't know what ethanol is. You are passing oxygen and you are heating. Obviously, the sample is going to burn. When sample burns, if this is burned with oxygen, what does it make? Carbon is oxidized to CO2, and hydrogen is going to be oxidized to water. So I need two traps. One trap is to absorb the water which is produced, and then another trap which absorbs CO2. So I measure the weight of this trap, and this is filled with sieves which absorb moisture. You probably have seen when you buy a camera or any material which is sensitive to moisture, they place a bag of these sieves. These material are desiccant. They absorb water. They keep the sample dry. So when water goes through this, it's absorbed by moisture absorbers, the weight is changed. If I measure the mass of this trap before and after, then I know how much water was produced from combustion. I can do the same thing with CO2 trap. I can measure the mass before combustion, and after combustion, I know how much water was absorbed. Guys, by simply knowing the mass of water, the mass of CO2, I can go from mass of water, I can go to moles of water. And if I have moles of water, you can go to moles of hydrogen. And from moles of hydrogen, you can go to grams of hydrogen. Same thing here. If I know mass of carbon dioxide, I can determine moles of carbon dioxide. I can determine moles of carbon, and I can go from moles of carbon to grams of carbon. So at the end, I end up having grams of carbon, and I know the mass of the sample. I can easily measure the percentage, which means mass of carbon in 100 grams of this sample. So at the end, I end up with percentage of carbon. This can give you the percentage of carbon, and this gives me the percentage of hydrogen at the end with simple calculation. I'm going to do an example for you. So I hope this makes sense, that by simply sending a sample to a lab which does combustion, I can determine percentage of hydrogen and carbon, and from percentage, I can write the ratio between number of atoms in the formula of the structure. And the simplest ratio between number of atoms in a structure is defined as empirical formula. So this is the setup. Suppose I have 11.5 grams of ethanol here, and we measure the mass of trap before and after. The mass is changed by 13.5 grams, which means 13.5 grams water is produced in this combustion. And I measure the mass of trap before and after combustion. The mass of the carbon dioxide trap has gone up 22 grams. So that's the mass of CO2, the mass of water from combustion. So if I have mass of carbon dioxide, grams of carbon dioxide, can I determine moles of carbon dioxide? Every mole of carbon dioxide is 44 grams, right? That's the molar mass. And if I know mass of carbon dioxide, is it fair to say there is 1 mole of carbon in every mole of CO2? So I have moles of carbon. And if I have moles of carbon, is it fair to say that every mole of carbon is 12 grams? So if I know number of moles, I know grams of carbon. And we know every mole of carbon is 12 grams, so half a mole of carbon is 6 grams. Another word, if you do the calculation, use 22 grams of CO2, you're going to get half a mole of CO2, half a mole of C, half a 12 grams is 6 grams. So 22 grams of carbon agrees to half a mole of carbon. You can check that calculation. Let me know if you couldn't get that. And if I start with 13.5 grams of water, I can determine number of moles of water. Every mole of water is 18 grams. And in every mole of water, there are 2 moles of hydrogen, so I can determine moles of hydrogen. And every mole of hydrogen is almost 1 gram. I can determine the grams. And if you do these calculations, 13.5 gram water is going to give you this information that in this structure, you have 1.5 mole of hydrogen and half a mole of carbon. That's what the calculation results to. I hope you can do the calculation on your own. Make sure you get these results. So we already know that in this structure, in ethanol, there is oxygen as well. So can I say, and this is what we do in the lab, mass of oxygen is, if you have a sample containing carbon, hydrogen, and oxygen, oxygen is always obtained by subtracting the mass of carbon and hydrogen minus total mass. In other words, I have mass of sample, 11.5 grams, minus total mass of carbon, 6 grams mass of carbon, and mass of carbon and hydrogen. So together they are 7.5 grams. So if I say total mass, which is 11.5, minus 7.5 mass of carbon and hydrogen, that would be mass of oxygen. So 6, 1.5, 7.5. Total mass 11.5 minus 7.5, do you get mass of oxygen? 4 grams. That's where this is coming from. Every mole of oxygen is 16 grams, so 4 grams is 1/4 or 0.25 moles of oxygen. Do this on a piece of paper. You don't have to accept my words for it. So the end result is this. We know number of moles of these substances. of these elements in the compound. So can I say I have carbon, hydrogen, oxygen, every 0.5 moles of carbon is coming with 1.5 mole of hydrogen and 0.25 moles of oxygen. So this is our empirical formula, except have you ever seen a formula which comes with fractional number, decimal point? No. When we write a formula, they should be integers. So can I divide all of these numbers by 0.25? And if I do, I get all these integers where you're going to see C2H6O just 1. So this is the empirical formula. So you see, we can obtain formula by combustion analysis. That's how we identify an unknown solution. And there is one more thing that we do in chemistry to identify the molecular formula. So far, this is empirical formula. It says for every 2 carbons, there are 6 hydrogens and 1 oxygen. But the molecular formula, I need one piece of information. So let's review what we did. So I started with weight of the sample. I run the combustion, I measure the weight of the CO2 and water. By using mass of CO2 and mass of water, I calculated moles of carbon and hydrogen. And then I divided all those number of moles by a smallest number to find the ratio between number of atoms. So I have empirical formula of the hydrocarbon. I hope this makes sense. So general method, just like any chemistry problem, you start with mass, convert to moles, find the ratio between number of moles. So the subscriptions of atoms are integers, whole number. They're not fractional number. But at the end, we are interested in molecular formula, not empirical formula. Another word, if I say C2H6O is empirical formula, the number 2 and 6 and 1 is simply showing the ratio between number of atoms. So this could be my real formula, molecular formula, or I could simply have C4, H12, O2. This structure also have the same ratio of 2 to 6 to 1. The same way that I said empirical formula for benzene is there is 1 carbon for 1 hydrogen. The real formula, which has ratio of 1 to 1 to carbon and hydrogen, could be this. 1 to 1 ratio. It could be this. 1 to 1 ratio. It could be this. C4, H4. Again, the ratio is 1 to 1. Or is it C5, H5? Or is it C6, H6? These are all possibilities. They all have 1 to 1 ratio of carbon and hydrogen. So empirical formula is CH, which is the real structure. Now I have to use molecular mass. In other words, if this is the real formula, the molecular mass is going to be 12 plus 113, right? If this is the one, molecular mass 12 times 12, 24 for 2 carbons, plus 2, 26 gram per mole. 26 gram per mole. So on and so forth. If this is the one, the molar mass is 78 grams per mole. In other words, now, in order to decide between all these formulas going from C8 to C6H6, is which one is the real formula? If I'm going to do that, I need molar mass or molecular mass. Well, when we measure the molecular mass with the empirical formula of CH, molecular mass is obtained by a machine which is called mass spectrometer. Mass spectrometer takes this, measure the molar mass. It says it's 78 grams per mole. Obviously, this is 13 grams per mole is not the answer. This is 26 grams per mole is not the answer. It's only this one which has a mass of 78 grams per mole. Now we say the formula, although the ratio between carbon and hydrogen is 1:1, however, molecular formula, the real formula is C6H6. So in addition to empirical formula, we need the molecular mass. Combine these two pieces of information to come with molecular formula, the real formula. So these subscriptions, in this case, the subscription is 6, is coming from molar mass